revise the shell programming. Input statements, which is normally used in Linux, is the read commands or the read API, read X. If you write this, the value can be stored. Whatever the value you are going to enter it from the keyboard will be assigned to the variable X. So example for that may be, say for example, in a shell script, if you write it, say for example, so if you write a program statement echo is very much similar to the printf statements in C programming language. Echo, say for example, enter a number, and immediately below that line you can write read and give some variable name, read X. And after that, whenever you want to print the whatever the value or the echo, once again entered number is, then you can print it out with the echo commands. Echo, then you can write dollar and variable name. Okay, dollar and variable name you can write. Hello. And similarly, there is one more command that you need to remember about as far as shell programming is concerned or shell coding is concerned, about the exit commands. Whenever you want to terminate a loop statement or a program, we can use a statement called exit. The convention is that we will write exit 0. It is for a normal termination. Normal termination of a shell program if everything is fine. In case if you are able to catch any error signals, error, etc., then you can give a non-zero value, normally exit 1. So you can use it for errors if any. So when I say error, if you are able to catch any errors, you can go for this kind of commands to get the very user-friendly outputs. Then as far as the logical operators are concerned, whenever in the last class we discussed about different conditional statements, etc., where if some condition, etc., there we can use logical operators. The technique is once again here almost similar to C or C++ programming language. You can write, say for example, you can use, say for example, one command, then you can say AND operation. You can say, for example, command 1 and command 2. So you can use AND operators. Similarly, this is the logical AND operator. Similarly, this particular symbol is for logical OR. If there is a command X or Y, if any one condition is true, so you're going to, and this particular logical operation will be result in the logical 1 or a true condition. So these things you can use not gate, not operator and operator, logical and operators, logical XOR operators, etc. You can nest it together. Coming back to the if statements, so you can write if is the command, so the conditional operator. Then you can write some condition here. If condition is true, some logical expressions you can write it here. If the condition is true, then you can write, then you can execute some different commands. Important point to remember here is the keywords if, then, etc. And you can go for else also. Else, and if there is some condition, that also you can write. And at the end of the if statement, you can write fi. Else is a keyword, fi is a keyword. Okay. So this is one way of writing form, one way of using if statements. Take it down. It will be very useful for you for a quick reference. So here also series of commands. So another form of writing this is you can write if, then say condition is true. Then you can write then if, and you can finish it here itself, fi. So in this case, then is a keyword, fi is a keyword, if is a keyword. Okay. So here comes the commands. So this is another form of using the if condition statement, form 2. Also note that you can write if condition is true, you can write then, you can write some commands here. Then you can write, look into this, else if, ELIF, not else if, ELIF. Then you can write condition is true. Then you can write again a then statement. Then again you can write else if, sorry, condition is true. In this way you can go up to any length, and you can write finally else. Do this. Then you can write finally entire series fi. So here in this way, multiple ELIF else if statements is a nested else if statements. Nested else if statements can be written. See, it's similar to the C language also. You can write it in this way. So note that if some condition is true, then you're going to do series of sets, command sets. Then again a keyword else if, ELIF. Then you can write some condition. Then if else if another condition is true, then you can go for execution of command set 2. If you want, or if it is needed for your program solution logic, then you can write once again else if multiple. In this way you can go on nesting it, some other condition. And then comes another command set, series of commands, one or more commands can be there here. Then finally once again, so here also then is also keyword. Then again comes, you can end it, end this series of else if, something like this, else, instead of writing else if here at the end, else you can write if all above conditions are not true, or not satisfied, then you are going to set execute command set 3 or 4. Command set 4 in this particular example. Then you can write, but now note that at the end of the if statement, you need to indicate end of if else if series with the fi statement. So every if statement ends with the fi. These things you need to remember in if series statements. Now let us discuss this if else statement, particularly maybe a form 1 or 2, or sorry, form 1 type of statements. How we can use it practically. Let us try to write one simple shell program. See, in any shell script, whenever you're going to write a shell script, this can be your first line. See, what is the meaning of this command? Hash, then exclamatory mark, /bin, /sh. Here, this can be replaced with the various shell programs. If you are writing shell program with the bash scripting language, then you can write bash here. Otherwise, if you are going to write your script using C shell, then you can write CSH. There is one more variety of shell scripting language exists that is called con shell. Then you can write KSH, etc. But for the moment in this discussion, let us discuss it with the bash. So in case if you're interested, there are other options for you to select a particular language. In that case, and the different, there may be a slight difference between syntax also, and sometimes in features also, you may find it some differences. Okay, now coming back to the coding part. Now assume that, now look into this, tell me what is the meaning of this program. If grep, then you can write some condition here. You are searching for a particular password file, etc/password. So here actually we are searching for the beginning of searching for the beginning of line in /etc password. Standard output, then we want to redirect it. What is the meaning of this feature? But we'll discuss it a little bit later. It is about standard input, standard output, and standard errors. Actually, what happens here is that searching for a username /etc/password file contains username, user ID, group ID, password, etc., in one particular file stored in encrypted format. Here you are searching for a particular entry. Okay. You are searching for a particular pattern, search username at the beginning. Now, whenever we are going to, now here, what is this? What is the meaning of $1? Try to remember what we discussed it in the previous class. $0 indicates the program name. $1 indicates the first argument. Is a command line program. During the compilation of the code, you are going to enter some value that is stored in this particular variable $1. So we are searching for that particular name in the beginning of a line. That's why that is what this symbol is indicated here. We are searching for the beginning of line for a given string. Here it is mentioned as $1. That means that value will be supplied by the user during the execution of this script. How to execute will discuss it a little bit later. You are searching for a particular string assigned to $1 in /etc/password file. So if this particular condition, if there is a match, if you get this condition, say this everything is a condition now. If this condition is satisfied, if you get this particular output, okay, whether it is, if you found it, it will be 1, otherwise it will be 0, this particular condition, then you say that echo something like a pattern found. Otherwise, you can write else echo pattern not found. You can write it code like this. So if then else, then if it is, if you want to terminate it, okay, write F5. This is beginning of the if statement, end of if statement. Now, how to execute this code? That's very important. Now we assume that this entire code is stored in, say, for example, myscript1.sh. Assume that this is the script name for the above. Script name or file name. This entire content, you will put it in a text file. That is what is a script. And if you store it as myscript.sh, in the command line, you need to execute this with the // myscript.sh. This is the first argument, and you have to tell the compiler to the script what you want to search for, what pattern you want to search for. Assume that you are going to say, see, I will enter my username, Manmohan, in my Linux system. So now, listen carefully. This is what we say writing a command line script. Here, this particular statement is the execution command. The first part that will be stored in $0 automatically. You need not store it explicitly. There will be an environment variable $0. For that, myscript.sh, myscript1.sh will go there. And the second part, whatever I entered is Manmohan, that will be stored here in $1 automatically. So that's why look into the script back here. Look into this particular statement here. If grep $1, okay, this cap indicates that beginning. If that line begins with the Manmohan in /etc password, in /etc/password, if there is any line starts with the Manmohan, then condition is true. If that condition is true, then it will say that the pattern is found. Otherwise, it will say pattern is not found. So this is one simple example. Similarly, you can write different programs on this. You can develop different programs using these if statements. And the next question is about evaluating the expressions. Even in the last class, there was a question like if everything is as a text, then how we can add, subtract, multiply, etc. Now let us discuss about it a little bit. Okay. Now say, for example, in a shell command, forget about the shell script for now. Now assume if you write assign one value x equal to 5, write a semicolon, and you can go on assigning values like this, y equal to 7. And again, if you say, once again, z is equal to 7.2. Okay, type is also very important here. It's a decimal point. It's 7.2. Now, you can test this number. You can evaluate if you want to use these numbers, the value stored here. comparisons. Then you can write in the next line, there is one operator called a test. Remember, you have to write test. Then write $x. If it is equal to $y, then it type this echo $0. Sorry, $? Now look into this. What is this $? Here? It's very interesting. What is $? Here? This is also one of the shell variable. And even in the last class, hope we discussed about all these $? Also. This is nothing but exit status of a program. How this program, this is exit status variable. Okay. This will indicate exit status of last command. Okay, last command is obviously here a comparison. So in this comparison, what happens? What is the output? Okay, this is what to say. If here the test, when you test it, there is no match. It is not matching. X is actually 5 and Y equal to 7. So this comparison fails. $x, then hyphen EQ you're writing, you're checking for equality. This test fails. So automatically exit value becomes 1. If this test is successful, that means if X is equal to Y, then exit status will become 0 automatically. Okay, this is the characteristics of the shell variable. $? Is a shell variable. We are just checking it. So test $x hyphen EQ $y, then echo $? Automatically this echo $? that will output the value of exit value. So now here it is not equal. So naturally the output is 1. You can test this in your shell command. If you have a Linux machine with you, check it. Don't trust it blindly. You type this code carefully and check it out. So this similarly, you can go for another test condition. You can use the test $x. Okay. If it is less than LT, hyphen LT, I can press less than $y, then try to print exit status. So now you know this is equal. Actually, X value is 5 and Y is 7. Naturally, $x is less than X is less than Y. So condition is proved. It is right. So exit status, whatever you're going to get will be 0. Similarly, you can find out say another test condition, test $z is greater than $y. Echo $? Now what will be the output? Anybody? Can you tell me what will be the output? Either it is 1 or 0.
0.
0. Why? Why it is 0? Tell me that.
Greater than.
So now here it is, you may say that Z is 7.2 and Y is 7 and echo $y, but here it may surprise you, it will say 1. Because here you are not going to compute the numerical value. Okay, this is very strange here. Okay, 7.2 is not greater than 7. Okay, So what is the reason for this? Here the problem is that there is a decimal point here. So because of that, but here in this special case, it says that it is not greater, it gives you 1. The reason we will examine in a little bit later stage. And again, if you say one more thing, say for example, test, if you say $Z hyphen EQ equal $Y echo. Now if the exit status, actually $Z is nothing but 7.2 and this is 7. Now it says that yes, it is equal. The problem is that only the integer part is considered here. Okay, if you say 7.2, that is ignored. Only integer part is considered. That's why here also 7.2 is also considered as a 7, and y, of course, value is 7. Actually, it is equal. It will be considered as equal, not greater than. That's why it is failed. Here, you are testing that for equality. Both y and z tested for equality. It says yes. So integer part is considered here. Decimal point is ignored. Okay, this is the one of the, because it is not a complete programming language. So you need to remember these characteristics of a shell. So in the meantime, once again revise, say for example, hyphen EQ is for equal to, you're writing hyphen NE for not equal to, and hyphen GT is for greater than, and hyphen G is for greater than or equal to.
Excuse me, sir. So can you explain the exit status 0 and 1? I'm a little confused on that. Why did it give 0 and that give 1?
See, whenever the previous statements, your previous set of statements, now look into this particular command here. Once again, I will point to that. Look into this particular statement, test $X equal $Y echo $0. Now here what happens here is that $X and Y is tested for equality. That was the first statement here in this line. There is a semicolon here. This operation is performed first. Equality test, X and Y is checked for equality. Now what is the condition? It is a true or false? Condition is false. Now this is no condition is not satisfied. You're checking for equality, but it is not equal. You are attempting for a equality test. Your equality test is failed. It is not equal. So we can say that it is. That's why it says exit equal to 1. Whenever some test, some operation fails, then it says that 1. Exit status equal to 1. In case if you are checking for test 5 equal to 5, then it will say yes, equal. Yes, it is, you are right, equal. Then there is no error in your assumption. So exit equal to 0. Exit value will become 0. Okay.
Then, sir, in test, $Z equals $Y. Why do we still get 1? Shouldn't we get a 0? Because if this is assuming Z to be 7, the last command.
Last command, okay. Here, last command, you are checking for Z and Y, right?
Yes, sir.
Z and Y, you are checking for equality, right? So when you check for equality, Y is, of course, the value is Y. Z's value looks like 7.2, but Unix takes only the integer part. If you directly use a variable, decimal point is ignored. It will not be considered. So what is the integer part of Z?
It's 7 only, sir.
7. And what is the value of Y?
7.
7. Whether your equality condition is proved,
It's satisfied, sir.
the condition, yeah, what happens in that particular case?
So if the
The,
condition is satisfied, it should be 0,
yeah,
right?
yeah, sorry, yeah, I made a mistake here. It should be 0. But this condition, because both are 0, okay, the condition is satisfied. In case if you are checking for z equal to y, then return value will be 0. But here, if you test for the just look into the previous one, you are checking for greater than. Then it says that it is not greater than. Actually, it is equal, not greater than. Z is not greater than y. Okay, you are not greater. That's why it says 1 error. Your assumption is error. You assume that Z is greater than y, but it is not so. That's why 1. If you can, so the last part it is 0. You are right. Okay, it should be 0. Thank you for noting that.
Thank you, sir.
Yeah.
Sir, do
If
we
you,
have a way to even consider the decimal point?
pardon?
Do we have a way to even consider the decimal point in these operations?
I will come to that later. In the later part of the code, there are some other features we need.
Okay, sir.
Okay, there are some other options you have, and we are doing it in another method. Whenever you want to divide two numbers, say something like 3 by 2, etc., you will get numerical values, or you want to add two decimal numbers, etc., or the numbers with decimal points, etc. Then there are other methods. So that we'll look into that later. Okay, now coming back to these equal symbols, logical operators, comparison, the numerical comparison operators used by test command. One is equal, not equal, greater than, and equal is GE. Then LE for less than, hyphen LE for less than or equal to. Okay. So, and also note that there is now here in this all these particular commands, you are testing this, or you performing this equation analysis using test command. But there is a shorthand method also to perform this. Say, for example, this entire command test $z hyphen equal to test y, you can put it in a bracket, square bracket. You can write it with $x hyphen equal to $y, and you need not state it as a test. Simply write, you need not use the test command, but instead that entire expression you put it in a square bracket. So in that way, if you say, for example, your first commands, this entire statement, okay, you can put it within the square bracket $x hyphen eq $y without using test. So that also will work in a shell script. Similarly, strings also can be tested. Okay, so you can go for a, say for example, string test used by test. How we can deal with the strings. So the test command, you can write, say, string 1, whether it is equal to string 2. If S1 and S2 are the value, read S1 and read S2. If you write and if you assign some strings to it, you can check whether two strings are equal by S1 equal to S. So that means that you can put it something like this. You can test. This will say true if string S1 equal to S2. Similarly, you can write S1 not equal to S2. Here, that means Here the meaning is that string S1 is not equal to S2. Then there is one more command. If it is -n and if you say some string str is not a null string. Take it down, -n and string name. Here string or some any strings, string str. Similarly, you can test it for null string using -z. -z, and if you write some string here, that means that you're testing it for string str is a null string. If you write simply some string name here, this means that string str is assigned and not null. There is some dot value is stored in that. That is the meaning if you write simply str. Okay. And in some shells, say for example, S1 equal to S2, like C, like programming structure is used for equality. Okay, in some shells, this will look into the difference. And sometimes you have to check it in your shell. If it is a bash, normally the last one, S1 double equal to S2 will work. So string S1 is equal to S2. But this works in corn shell and bash only. In other so in other C shell, etc., the first method works. So these things you can use it along with the strings. Whenever you are using working with the strings, you can use these techniques. Say you can say read string one, read S1, read S2, two strings. Then you can check it for equality, whether two strings are equal or not, whether it is null or not, whether it is a null or with not null. -n, you're checking with the string name, you're checking for not null condition. If you're checking whether it is a null, then you have to say -z and string you have to test. So all things we are using with the test commands. Okay, along with the test, we are using these operators, test command. So try to use this command with some strings and try to write some simple program. Okay, and practice it. And you can also check. So now when we say, whenever we create so many files we create, these file also we can test, file tests. It is not FAIL, it is FILE. Whenever you create a text file or any data files, you can perform different checks on those files. What are the different checks you can perform on a file? So here also we can use the test commands. Okay, we can use the test operator and you can write it. Now here, different tests that you can perform on any file is along with the test command, and whether it is true or false. True if file, you can put it in this way. And all this series of next, whatever I am going to write this command, this works on your file name. So you have to say test command. Along with the test command, test command, you can test the conditions of files. Say first one is you can write -f and a file name. This indicates that. So how to use it? You have to use it with the test command and -f file name. Then what happens? Your test commands. Okay, that is the meaning here. Here, this means that file exists and is a regular file. A normal file created by user using VI editor or any text editors. Test -f file. Okay, if you use this -f and a file name, it will say true or false. True if the file exists. Now assume you wrote a program. The program name is test.c. If you want to check it in the present working directory whether the file exists or not, what you have to do? You have to write test, then -f test.c. This is the file name. Then you can say echo, and you can check the exit status. It will say if condition is proved, if file condition is exists, success, it will return 0. If file is not existing, it is an error. So it will say it exit status will be 1. Correspondingly, you can use if statement. If $y, you can display appropriate commands. Let us practice such commands in the next programs as well while we are practicing it. Am I audible?
Yes, sir.
Can you see the shared screen? Can you see it?
Yes, sir.
Yeah, because I am facing some problem here anyway. Now I will continue. So now when we say, okay, I will continue with that. What are the different tests on files? One is -f and a file name. So file exists if it, so another condition is -r and a file name. This means that file exists and is readable. You're checking for the read permission here, whether user has got read permission or not on a particular file name. -r file name. Similarly, because of read, then again naturally -w -x. Read, write, execute for file names. Here you're checking for file exists and it is writable. -x is file exists and it is executable. And -d, and if you write a file name, the given file name is a directory. It is a directory, etc. And again, if you say -s and file name, it says that file exists and file size is greater than 0. That means that it is not an empty file. That is the meaning is that it is not an empty file here. And similarly, -e and a file name. this says file exists. That's it. It will not talk about size, etc. Whether file exists or not is indicated with this. And again, -u, there is one more option. So anyway, for this particular command, I am not going to discuss. There is one more here. Okay, anyway, I'll just mention it. But what is the relevance? Just will postpone that discussion for later stage. This says that file exists and SUID bit equal to 1. What is SUID? Set user ID bit, and what is the use that we are going to discuss it in the later chapters. Okay, in this way, we can test a file for a different condition, whether a file is readable, whether a file is writable, whether it is executable, etc. Conditions can be checked using this the command called test on files. Then another command we discussed is the case. So this also we discussed it in the previous case. I am repeating these things because these are very much essential for future discussions. Case conditions. How to write a case. So this is very much equal to switch case statements. To avoid nested if statements, you can go for switch case statements. Look into the syntax here. You have to write case, then you write some expression. Say case x. Then what will happen? Value of x equal to 1, value of x equal to 2, etc. So some expression. Then you can write pattern 1, close the bracket, put the bracket, something like this. Then commands, series of commands. Then 2 semicolons you write. 2 semicolons. Then pattern 2 commands. In this way, you can go on writing different options, switch case statements. At the end, case CAC, write it in reverse, is ISAC, ISAC. So one case is ended with ISAC. These are the different options, patterns, various patterns. Now, say for example, how we can make use of it. How we can make use of a switch case. One example for a case statement, you take it down. Say for example, you're writing a program where you're inputting one value, read some value. Assume you're entering one choice 1, choice 2, choice 3, choice 4, etc. To do some task. You can check, you can go for if statement also. If choice equal to 1, what to do? Else if choice equal to 2, what to do? You can write else if choice equal to 3, what to do? You can go for a nested if statements, but we are not going to write nested if. Instead, we are using case statements. So if that is the case, you can make your program more compact. You simply write case here. Case within the double quote, the value of $choice, write $choice, the content you're checking. Case $choice in. So in is a keyword. Case is a keyword. Read is a keyword. Okay. Then now assume that choice may be something like 1, 2, 3, 4, 5, etc. Now you have to check that particular pattern. The pattern choice may be value 1. Put that value. Write it to 1. If choice equal to 1, put the bracket like this. Then do something. Now say for example, I will say that echo 1. And after that, I will come out of the if statement by writing 2 semicolons. Sorry, case statement. So if input value is 2, then I can write echo 2, 3, echo THREE. In this way, we can write. And if you expect only these, any other values, if you consider it as an invalid, then you can write star, any other combination, put the bracket, echo, invalid entry or invalid input. And you end it, ESAC. This is a small statement, if statement. You can write the same operation using if statement also. How you can write if choice equal to $choice equal to 1, then echo 1 else. If choice equal to 2, echo TWO, and so on. But you can put it with the case statement also. So any doubt in this? And also, it's very important to remember, sometimes you can go for multiple, matching multiple patterns also. So what is multiple patterns? Say, for example, in case if you want to say, now you have 1, 2, 3 choice here. If I say 4 or 1, 5 or 2, 6 or 3, you can use this also. Now, if you write like this, what happens here is that in case if the user enters 4, then echo 1 will be displayed. If user enters 1, choice equal to 1, then also echo 1 will be displayed. 4 or 1, then it will say echo 1. 5 or 2, then it will say echo 2. In this way, you can go for matching multiple patterns. You can go for matching multiple patterns. A very important variation of a case statement here. So multiple pattern matching. In case statement. You can use this also whenever you want to make use of this. Similarly, you can use wildcards also. So wildcards using star, etc. That is also possible. Anyway, that you can with some later on in the next class. I'm going to demonstrate the execution of some shell programs based on these things. That time I will explain that. Wildcard characters also can be used. And next part is about computations. Now, say for example, so if you want to, if somebody enters x equal to 5 and y equal to 3, then you can later on you can write, if you want to add these numbers, you can write expr, and you can write x plus y. So generally exr 3 plus y, it will you will get answer 8. Okay. In the and similarly different division operators also you can perform, division also, subtraction also. You can also say expr $x plus $y also, or you can write $x minus $y also. Correspondingly, you will get the answer with the expr commands. Okay, expr is a command that can be used for computation. Here also note that only integer computations you can perform with this. Next is the while looping. So, in fact, remember, I'm repeating this for you people, and remember this forever. Particularly, the students will get confused with C program and shell commands. That should not happen. So there are some small differences in writing or in the syntax part of it. That you need to remember. Then after that, you should be in a position to able to club together different programming constructs, inserting one case statement in a while statement, or inserting one if statement in a switch statement, sorry, the case statements, etc. You need to develop that particular skill while writing a program. Same is true for any programming language. Syntax or the program constructs, only the grammar rules we study here. Then it is up to your ability to mix that everything so that your program can be solved in a very simple way. Say while looping, the syntax is keyword while, then some condition. If this condition is equal to true, then you write and execute the following set of commands and done. This is the syntax. Note here, while is a keyword. You have a conditional statement. Any logical operators you can use. If y equal to greater than whatever, any logical condition statement which ends with the true or false. Okay, 1 or 0, logical 0 or logical 1. While then a do is a keyword, then so commands, any set of commands, then done. You're ending. This is the general syntax for a loop statement. Within the loop statement, you can embed a switch case statement also if it is needed. In the same logic, for loop, condition is for is the keyword, then variable, then rate in, then you can give a list of numbers, then write do and done in between multiple statements or commands. So for is a keyword, in is a keyword, do is a keyword, done is a keyword. Here it is programs. The example, say for, you can write x in, you can write a list of numbers 1, 3, 5, 7, 9. Then you can write do echo $x. Echo $x you can write. Then you can write done. Then it will print 1, 3, 5, 7, 9 from this particular list of numbers, whatever you wrote here. This is a list. There is no limit. You can go on adding other numbers also in any pattern, separate number, any sequence, one after another. This number, the
So-
list numbers will be assigned to X. Yeah, any doubt?
So can we take that list as an input from the keyboard?
Which list? Then
List for loop.
then you have to write a dollar. You have to give, whenever you are taking it from the keyboard, you have to assign it to a variable name, right?
Yes, sir.
Yeah. Then you have to if you assign, say for example, if you say x equal to 5, how to take it? You have to say echo $x to display. So in that way, try to find out what happens, how we can take the input from the keyboard. Is it possible? Whether that list of numbers, what are the other variations? Try that. Now, even the file names also you can give here. Not only that, you can give file names also. That's very interesting. In case if you want to display all the files starting with some patterns, you can list those patterns here or the file names, and then you can try to display that. So while writing some simple small programs in the next class, we will discuss about many different features of if statements here. Try this, whatever you want to test it. There is nothing will happen until you take one hammer and smash your laptop. At the maximum, you will get one error message. That's it. Only that is the only way of learning how a program or any programming language for that matter. Okay, this about loop statements. Now, having studied this, so programming constructs. Now, can we try to solve some problem? Say, for example, one simple problem will be write a shell program to find largest of three numbers. Take the values from the keyboard and then how you can write a program. So logically, you need to know how to solve it. In the first year PSUC, many of you wrote all these simple programs. So can you write a shell script for it? Can you do it with the Linux shell script? So as usual, hash colon, then you can write /bin /bash, then take int numbers radian1, radian2, radian3, then use program constructs. How to use it? If either you can use a test command or see a square bracket dollar n1 is greater than dollar n2. Then what to do? Go for the logic, develop it. Else if what to do? Different conditions. So you can try to solve this program, write this particular program and try to solve it. So you may use if condition, else if conditions with this program, with this small program to solve it. Similarly, if I tell you to write a program to the second program for you maybe to work out to take down the program, first one is write a shell program to find the largest of three numbers. Second one is write a shell program to find sum of natural numbers, sum of n natural numbers, sum of n natural numbers. Take the value of n from the keyboard. If you say n equal to 5, 1 plus 2 plus 3 plus 4 plus 5. If n equal to 10, then you have to add numbers from 1 to 10. In the same way, I can tell you to find sum of n natural odd numbers, sum of even numbers between two given ranges. All these small programs, you try to write it. If you face any problem while writing these programs, you can communicate your problem to me, maybe in the Teams, MS Teams, and we can discuss. Okay. Now, having said this, I will stop discussing for this week. In the next class, again, we'll try to solve some simple problem. At the end of the day, by next week, every student should be in a position to write simple shell script to solve some simple problems at least. Okay. Any doubts in any of the aspects discussed so far? We discussed about case statement. We discussed about for loops. We discussed about while statement. We discussed about test commands, testing a file, testing for different conditions like whether for the read permission, write permission, execute permissions, etc. With these concepts itself, we can try to write several different simple shell scripts. Okay. Any other doubts for the discussion? If there is no doubt, I will wind up the class. Anything you want to? Any queries? So instead of mugging up, you should know practically how to solve it, how to approach to the problem in a very, very practical and a natural way. Very important. Any doubts? Okay, then I will wind up the class for today, for all. See you in the next class. And before coming to the next class, you solve these few programs, some simple programs in shell using all these program constructs. Somehow you can use, you can write your own program. You can search for your own problem statement. All I want is that you are able to use a case statement. You are able to write a while statement in a script. You are able to write a for loop statement. You are used to, you know how to evaluate some simple mathematical expressions like addition, subtraction, multiplication of 2 or 3 numbers. How to go for conditional, use conditional operators, logical operators, etc. Okay, see you in the next class. Bye. But today attendance,
Thank you, sir.
yeah, today attendance is only 34 is showing me.
Thank you, sir.
Yeah, see you in the next class.
Thank you, sir.
Bye.
Thank you, sir.